Now let's talk about ionic bond, or that we can also say electrovalent bond. So it is ionic bond, and or it is a electrovalent bond. Now if we see, whenever chemical bond is formed by complete transfer of electron, whenever it is complete transfer of electron from one atom to another atom, then it is named as ionic or electrovalent bond, and it is a non-directional in nature. It is a non-directional in nature. Okay, non-directional in nature means the bond is non-directional. It don't have any direction. Like if we talk about the example, potassium in solid state combined with 1 by 2 Cl2, and it forms potassium plus and Cl minus. So you know that what is the electronic configuration of 2, 8, second shell 8, third shell 8, and fourth shell it is 1. And what about chlorine? It is 2, 8, 7. So here potassium, what we get, it becomes 2, 8, 8, and chlorine also becomes 2, 8, 8. Okay, it is getting similar, that is by chance. But here the main purpose is to complete transfer of electron to make their octet complete. Okay, so that here that bond is there. Okay, so here net energy releases. Okay, net energy releases. Okay, here net energy releases. That's why we talk about this, that it is a ionic bond. Now if we talk about the formation of potassium solid from to react with chlorine and form potassium chloride. Okay, here we know the net energy should releases. Here net energy should release, there only bond formation is possible, because whenever the net energy releases, it get more stability. Net energy, from net energy, okay, energy net, it get more stability, then only bond formation is possible. So we know, whenever we know the Hess law. Okay, we know that whenever potassium solid, first we have to sublimate it, then after sublimating it, then we have to make it ionization energy 1, then after ionization energy 1, it converts into potassium plus in gaseous state. From we know that 1 by 2 Cl2, but we have to dissociate it. When we are dissociating it, half of the delta in dissociation, that will forms Cl in gaseous state. Then when electron affinity 1 is Cl minus in gaseous state. We know that when the bond forms from its isolated gaseous ion, then the energy release is known as lattice energy. Okay, so that is lattice energy. Okay, it forms in a solid state. It is in solid state. So we know Hess law, the delta H formation should be summation of sublimation, dissociation, ionization, electron affinity, and lattice energy. So we know that when the net energy should release it. Okay, if delta H has to be negative. Okay, we know that if delta H formation is negative, when it will be negative, when these are known as these are known as the required energy. These are known as required energy, and this is known as released energy. So we know that the released energy is greater than the required energy. Released energy should be greater than the required energy. Then only bond formation is taking place. So what are the condition for ionic bond formation? Okay, what is the condition for ionic bond formation? What is the condition for ionic bond formation? So we know that the net energy should be delta H formation should be negative. For delta H formation should be negative, then the cation should have, this value should be low. Okay, so cation should have less low ionization energy, and what else? The atom forming should have high electron affinity. Okay, atom forming anion should have high electron, atom forming anion should have high electron affinity. And the third point is, amount of energy lattice must be substantially high. The lattice energy should be substantially high. So these conditions three condition we should be here. How we can understand that? That we know that these energy should be higher than required energy, then only delta H formation will be negative. To form delta H formation negative, that means it is the favorable condition to form the bond. So cation should have low electron affinity and atom forming cation. Okay, here we are using atom forming cation. Atom that which are forming cation should have low ionization energy. Atom forming anion should have high electron affinity and lattice energy should be substantially high. So these are the three conditions for to forming the ionic bond. So now let's continue with covalent bond. So whenever chemical bond is formed by equal sharing of electron, it is equal sharing of electron. Whenever it is formed by equal sharing of electron between non-metals, then it is named as, whenever chemical bond is formed by equal sharing of electron between non-metals, then it is named as covalent bond. It is a directional in nature. Electron between non-metals, okay, then it is called covalent bond. It is directional in nature. So we know that like example, when hydrogen combines with hydrogen and number Z is 1, then hydrogen Z is 1, then it forms H2. It forms H2. Here in the energy releases, net energy releases, and it has 2 electron. Next is Cl and Cl. If we talk about Cl plus Cl, the 2 8, 7, here also we have 2 8, 7. Then it is forming Cl2, Cl and Cl. Then it is again 2 8, 8. The sharing of electron 2 8, 8. The net energy release. What do we mean by sharing of electron? Well, let's take an example, like we have two business partner. Okay, business partner. Okay, so now what does sharing means? Okay, like we have two business partner. So what does the sharing means? Sharing means like it has 50k bucks. It is also have 50k bucks. Now they are sharing. Now the common bank account will have $100k. Okay, like it has 50k dollar. It is also having 50k dollars. Now they are opening a venture. Now bank has $100k. Now the amount of bank, so we can say now how much money that a partner have. It is now have $100k. Now we also have how much money it has. It has again $100k. So when they are sharing means it can also be used by A and it can also be used by B. So that will call the sharing of electron. Okay. So here again, if we talk about these electron, they have common 2 electron. Okay. So 2 electron also using by this, 2 electron is also using by this. Again 2 8 8. He is sharing 1 electron. Okay. So these 2 electrons are there. Okay. Here also these 2 electrons are shared. So it has also 2 electron. It has also 2 electron. Now if we talk about chlorine, it has shared this electron of that chlorine. Okay. So 2 8, 7. Now it has one more electron. Again it took 8, 8. Now they are form a sharing of electron. So here we know if we know number of bonds, how many number of bonds we see? It is number of unpaired electron in ground state, or excited state. In ground state or excited state, that is in ground state or excited state. So now we know that if we talk about oxygen, if we take an example of oxygen, and now it has 2,6 electron, and again if we talk about oxygen 2,6. So these require 2 more electron. It require 2 more electron. Okay, to complete octet. Okay. So now we know octet rule, that atom try to complete its octet. It is the most stable state of the atom. So now it will be having 2 bonds. Okay. Now again, what is the configuration? 2 8, 8, because these 2 electron of oxygen is used by this also, and 2 8, 8, because these 2 electron also used by this oxygen. So if we talk about the sharing of this oxygen, like this is the sharing of this oxygen and this is the sharing of this oxygen. So again it has octet complete. Okay, it has octet complete. Okay, so that's how we will answer. If we talk about nitrogen, in nitrogen, if we see the nitrogen, the electronic configuration is 2, 5. Again, if we talk about nitrogen, the electronic configuration 2, 5. It needs 3 more It need 3 more electron. Okay, so now it nitrogen and nitrogen and nitrogen. If we have what is 2 8 comma 8, here also it has 2 8 comma 8. So we know now if 2 bonds are there, first is sigma bond and rest are pi bonds. So here also one is sigma bond and these two rest are pi bond. Okay, so that's how we will categorize the bond. One bond should be sigma bond and remaining bond are categorized into the pi bond. So we know that H2, the hydrogen, the Cl2, the O2 and N2, the hydrogen Cl2, O2 and N2 form non-polar covalent bond and form non-polar covalent bond. So that's how they form the bond. Now let's take some cases where the bond formation is due to energy release, not due to complete octet. Okay, where bond formation is due to energy release, released, not due to completion of octet. So now we know hydrogen fluoride, here it has 2 electron and it has 2 comma 8 electrons. So this is also not an example of completion of the octet. If we talk about hydrogen chloride H, it has 1 electron in its state and it has 2 comma 8 comma 7 electron. Now it forming HCl which has 2 electron and it has 2 comma 8 electron. So again if we talk about H comma H, hydrogen hydrogen oxygen hydrogen oxygen hydrogen. So it has 1 it has 2 6 electron and it has also 1 electron. So it has O, H and H. So H it is 1, O it is 1 and it is 2 8. Now if we talk about BeCl2, so in BeCl2 Cl is 2 7 and beryllium is also 2 2. Now again it is also 2 7, chlorine is also 2 7. So it forms BeCl2, BeCl and Cl. So Be is 2 4, here it is 2 8 and here it is 2 8. Again the net energy is being released here. Okay, the energy is released. It is also in completion of octet. Again if we say PCl5, so P plus 5Cl. Again phosphorus has 2 8 5 and chlorine has 2 8 7. So it is forming PCl5. Okay, PCl5. Okay, so P, here it has Cl, again it is a Cl, it is also having Cl and it is also having Cl. So all Cs has 2 8 octet, but phosphorus has 2 8 10. Again it is 10, which is not an octet. Okay, so these all bond parts are forming when net energy is released. Okay, here if we talk about the net energy is released. So this is also from Hess law. When net energy is released, it is getting more stable. That's how this bond is forming. Now if we see further now how the what are the categorization of, okay, like we have two terms. One is hypovalent and then hypovalent. So what is hypovalent means? Hypovalent means electron deficient compound. These are electron deficient compounds. So these are electron deficient compound. So the covalent compound in which the central atom is less than 8 electron. The central atom is having less than 8 electron. So in this valence shell is called hypovalent, and electron deficient compound act as a Lewis acid. So these act as a Lewis. So now these act as a central atom, act as a Lewis acid, act as a Lewis acid. So they act as a Lewis acid. Like example BeX2, where X could be chlorine, fluorine, bromine, iodine. Okay, now if we talk about again BX3, so X could be again all the halogen, fluorine, chlorine, bromine, iodine. If we talk about AlX3, again X could be chlorine, bromine and iodine. Again aluminium hydroxide, and BOH whole thrice. Okay, so this is boric acid. So these all are having a central atom deficient of electron. Okay, these all central atom are having deficiency of electron because they are not a complete octet. Okay, having less than 8 electron. Okay, so these are known as hypovalent. Now if we talk about next term, what is hypervalent? Hypervalent, again hypervalent, the term you can understand that it is also known as superoctet compound. Okay, this is also known as superoctet compound. So the compounds, covalent compound in which central atom is having more than electron. Okay, central atom is having, okay, we are talking about here covalent compound. Okay, covalent compounds in which central atom having more than 8 electron in its valence shell, more than 8 electron in its valence shell, then these are called hypervalent compound. Like example, if we take about XeF2 xenon fluoride, XeF4, XeF6, PCl5SF4, SF6, SO4 minus 2, PO4 minus 3, CEO4, ClO4 minus etc. These are known as hypervalent compound.